This program is brought to you by Stanford University. Please visit us at stanford.edu.
Thank you very much for that kind introduction, Marty. And I want to thank all of you for coming out. I'm absolutely amazed on such a beautiful night that we have such a wonderful turnout. It must be because of the fireworks that are going to follow. I was referring to the good questions I'm going to get. Okay. Well, talking of fireworks, this is a topic which is often very controversial in the media. So let me ask, first of all, since everybody here, I presume, has heard of global warming and listened to some of the debates, how many of you get your information from the primary scientific literature, Science, Nature, and other papers? Right. Now, given it's a Stanford, that's like 20%. That's a lot for most audiences I do that aren't, universities and an evening talk. How many get it from websites and science TV programs? All right, that's a larger percentage. How many get it from the evening news and the newspapers? Right, that's about equal with that. And that's pretty typical. In fact, the vast bulk of audiences that I'll talk to in after dinner talks, most people get their information from the media. In fact, I asked that question when I talk to public groups in graduate schools and undergrads and high schools and even junior high schools, right on down to congressional committees. And good, you're awake. And most people get their information from the media. Now, we all know how the media operate. They operate on the basis of truth. On the basis of ratings. And because after all, it is a business. And that's not true for all, but for a large amount. And controversy is good for ratings. And it also is a good way to do honest reporting when you're covering politics. So if you're going to get a Democrat quoted, what must you do to be fair? Quote the Republican, exactly. And that makes absolute sense. But what happens when you translate that to a complex topic like climate change, and you quote somebody from a deep ecology group who says that climate change is going to warm up by 10 degrees, it's going to drive 80% of species to extinction and cause the Earth to become Venus, followed by somebody from an enterprise institute who says CO2 is plant food, it's good for you, it would be way too expensive to fix it, and why would you want to? So you get end of the world versus good for you extremes pitted against each other, and I'm going to confess a prejudice. End of the world and good for you are the two lowest probability outcomes in the debate. And when they get polarized on the op-ed pages of newspapers, on the evening news, and up until 2 years ago in front of Congress with those two, where you bring in real climate scientists and then you bring in the ones who are really knowledgeable, the two famous climate professors, you know them all. They get a lot bigger audiences than I do, Professors Limbaugh and Creighton. And, and you have to sit there and have this debate, and no wonder the public is confused. My God. The experts don't know. So if they don't know, how am I going to know? So let's just wait and see before we do anything. So this is a classical problem. And I don't blame the media for using balance in political reporting. But it's very rare when good reporters like Andy Revkin or Juliet Alpern at Washington Post or others here who know the science, they don't do that. If they're quoting somebody who represents a minority opinion, they label it that way. Because good reporting shouldn't leave out minorities. All good scientists should be skeptical, and we should welcome all new crazy ideas, because once in a while, there's a Galileo lurking behind that crazy idea. We got to check them out. But you don't immediately say, well, this new idea, which goes counter to the mainstream, has now falsified it. That was the trick used by the American Tobacco Institute for 30 years. Cite the 3 studies that were equivocal, ignore the 300 that were statistically significant, and claim that the 3 falsify the others until we've shown it. Even worse, they would argue, and rightly, well, we don't understand the biology behind how smoking and cancer are connected, so until that is fully resolved, let's not act, while ignoring the epidemiological evidence. And an analogy I like to do to that, because I hear it all the time, but wait a minute, you guys aren't sure about everything. There's a lot of elements. Even in your own reports, you admit all the elements that we don't understand. And that's true. Good and honest scientists must always do that. But do they or don't they trump the major part? And that's what I want to address first. Then I'll later on give you examples of it. So a question I'm frequently asked is in the media, how settled is the science? And I've been asked this for a long time. I actually can recall, I'll tell you some media war stories. Back when I was a postdoc in the National Center for Atmospheric Research that Marty mentioned I was at from 72 to 92, I gave a talk at the American Association for the Advancement of Science meeting as a postdoc. And I was talking about the basic understanding we were just starting to develop about what makes ice ages come and go. This is when we were just beginning to realize that there were greenhouse gases associated with when it was fewer, when it was cooler, more when it was warmer, not a perfect match, and that the bulk of it was due to changes in the Earth's orbital elements. So I made the comment that we would likely again have an ice age and 5 degrees cooling, and it would not be a very good thing for a world of back then 3 or 4 billion people, now a lot more. And the story was in the New York Times. It was a pretty good story. And I discovered, because NCAR, the lab I was at, had a press intelligence service. By that, it means, don't worry, don't think it's an oxymoron. And what they did is they would, anytime the name of the institute was mentioned, they would get a clipping. And they paid $1 a clipping, and that way they could put together a book about people from the institute who were being quoted. And the story in the Times was good. It got it basically right. And I think it was written by Walter Sullivan, who you'd expect to get it basically right. And it then progressed its way across the country. The better newspapers bought the story. They gave Walter's byline. They had the whole story. And as it started to move further into the hinterlands and into smaller and smaller papers, the byline disappeared. The special from the New York Times disappeared, to the point where I was also talking about weather modification in there. It became water modification in a dry zone. And the best of all was the story, which came from a small newspaper somewhere in the High Plains, and it came through the NCAR Press Intelligence Service. And one of my colleagues, who didn't think it was good for a postdoc to be out there making speeches that get quoted in the newspapers. You remember, you're supposed to get famous by hunching over the bench, and letting your work speak for you, not because you happen to be articulate and talking to a reporter. And so there was this article posted on the map room door, the map room for a meteorology shop, where the forecasts are. That's the central cultural spot. And it had BS stamped all over it. And when I read it, I said, oh, these guys aren't jealous, they're right. Because what happened is that this group that copied the story, it went on, it got the part about the Ice Age, but it didn't have much space. So it left out the last 2 paragraphs where I said in 20,000 years. So there's always a price to doing public outreach. And Kay Storm, who's here, knows all about this Office of Public Outreach. And I shouldn't tell such stories because it'll discourage scientists from doing it. And if scientists don't do it because we think that it's too complex and too dirty out there, just remember, then somebody else has to do it for us. And I don't think that's a more rational world than our trying to navigate it. But if we're going to try to navigate it, you don't want to navigate until you know the water. You better know where the rocks are. And therefore, it's part of what we're trying to do in the Woods Institute and in other places, which is to get people literate in the whole wide range. One more media war story, and then I'm going to ask you a question. I worked in the 1980s on a problem that, let's see how many people remember it, nuclear winter. Yeah, right. This crowd has enough gray, to remember that. I'm glad the youngsters don't remember it, and we've never had a test, which is very important. And the basic idea was that if you had a nuclear exchange and cities burned, it would put so much smoke in the air it would block out the sun and lead to winter-like conditions even in the summer. Well, that was based on a one-dimensional model, and therefore it was an on-off switch, so it was either freezing or it wasn't. I did a 3-dimensional model with my postdocs, And we discovered that there wouldn't be much effect in the winter because blocking out the sunlight when there isn't any anyway isn't going to make much difference. And one of my postdocs said, great, now we told them when to push the buttons. And we hadn't said anything in public yet. And I remember saying, wait, hold on. Anybody who needs to know the weather report after a nuclear war to be deterred further is already so insane that we're not going to reach them. And we got to tell the truth. But, how do you frame it? So we also discovered that there were going to be patches of smoke drifting around. So it would be fluctuating on and off in the cooling. So indeed, the basic idea, which was attributed to Carl Sagan, even though Carl was not really responsible, it was his students that were responsible, and they brought him into it. And because he had some ideas that were very, very important. But they used this 1D model, we used the 3D, and we found out the conditions were more like fall. And so we said, okay, we're going to call it nuclear autumn. We're going to tell people you can't grow crops in nuclear autumn, that it's going to knock out the monsoons, that 2 billion people will be threatened. I go morally numb after the first billion. I don't need to go all the way to the extinction of humanity. And so we tried to frame it this way. So I talked to a reporter working for the Boulder Daily Camera. He's a very good science reporter. This is a specialist. There are very few specialists left in the media. It's drifted over to blogs and general assignment reporters. There's an exception to that. And I'll take an aside. I was at a debate with a number of media executives, and a couple of us science reporters and scientists were really going after them for mostly firing their specialists who were capable of discerning the north end of a southbound horse and a lot of the junk that you get out there. And they just said it's business decision, and any good reporter can get the story straight in a day. I said, well, really? So do you send your general assignment reporters to cover the Super Bowl? And they said, no, that's different. I said, oh, I see. So knowing the difference between a stacked die and a spread formation is a really higher intellectual art than understanding cloud feedback, infrared radiative heat trapping, or the reliability of alternative nuclear reactor cycles. And then in the end, he said it's a business decision. So back to the business decision that got made there. So here was a reporter who wasn't in that category. He was a good science reporter. He calls me up at 11:30 at night because the story's going to come out the next day. And he says, I'm not responsible for this. And I said, Todd, what are you not responsible for? He said, you're not going to like the paper in the morning. I said, why? He said, I hope you'll like my story, but I'm not responsible. That's all I can tell you. I shouldn't even be calling you. So before I even get out there, the phone is ringing with hate phone calls from the peace movement and others. And finally, I go out there, I look at the paper, and there's a picture of me with a big smile, which they got out of the file photo, and it says, scientist says nuclear war not so bad. I don't think I'm helping, Kay, convincing people, right, that they should do outreach. But the story was actually very good. He didn't miss any paragraphs. It's just part of what happens out there. And I spend so much time on it because global warming is an issue which is just rife with this kind of stuff. So let me ask you a question now. I'm asked this question all the time by media and Congress and so forth. So before we're going to act, we want the science to be settled. How many think the science of global warming is settled? How many think it's not settled? How many think it's a stupid question? Right. Why? Because anytime you deal in complex systems science, like this one, there are going to be components that are well established, essentially beyond a reasonable doubt. There are going to be components that have competing explanations, and there are going to be components that are speculative. So polemicists will grab the speculative components and say, until they're resolved, nobody knows anything and should do anything. Speculative components do not trump well-established components, any more than well-established components imply that the entire case is solved. So what the Intergovernmental Panel on Climate Change does, what you mentioned, got a Nobel Peace Prize. And by the way, the 2,000 of us from the IPCC were very proud of that. So I probably had 10 jobs there. I figure I'm entitled to 1/4% of that. But so it's not on my vita as a laureate. But the thing that made me so proud of it was that when we when by sheer chance Al Gore was in San Francisco and he came down to Palo Alto to have the press conference, and 4 of us out of the 8 who are Stanford lead authors or contributing authors of the IPCC went to the press conference, there were 65 cameras. Now, they were not there to cover the IPCC, let's be very blunt. They were there because prizes are the cult of personality. And that's very effective. And it gets used in people's introductions tonight, witnessing that. And I don't object to that. What's really good is that when you have 2,000 scientists that have to work together, and the way the IPCC works is you have 200 scientists working for 3 years together. They write 3 reports. Each one is reviewed. You get something like 1,500 review comments per chapter, and then you have to justify every single comment, how you treated it, to 3 review editors who are independent from the report writers. And then you have to have 120 governments at a thing called a plenary when we all get together for a week who have to accept the reports, and you have to convince them you did it fairly. So we get a little frustrated when that gets sort of balanced against 2 guys funded by the Competitive Enterprise Institute with PhDs and given equal time in the media. And that often happens. But let's go back again to the settled science question and the issue of speculative and the appearance with the vice president. After 5 minutes, he finished, and there were 4 of us up there that were all the only 4 who happened to have been here at the time this happened, and he, much to my surprise, because he's very good at Q&A, often better than in giving speeches. That's where he shines, because he shows he's a very smart guy and he knows a lot. And he just turned over and looked at us and he said, the lead authors will handle the Q&A. Of the 60 cameras in the room, 55 of them folded it up and left. And I couldn't understand why he did it. The 5 that remained, which included ABC and NBC and CNN, was pretty good, and they did good stories. So it wasn't a waste of our time at all. We spent 2 hours with those groups, and print media and San Francisco Chronicle covered it, and AP covered it. Why did he do this? And then it occurred to me why he did it, because I finally found out from staff. Because what question would they have asked him? Remember, this was a year ago. Are you running for president? Who are you going to endorse for president? And he said, this is about climate. It's not about me. So what was so good about the Nobel, from my perspective, is it wasn't about the cult of personality on the IPCC half. It's about the culture of community. Because IPCC is a community. And what makes it so effective isn't the 200 scientists and the 3 rounds of reviews and the review editors and the 120 governments and a plenary which goes all night and is an ugly story that I'll tell you if you ask me later. It's that there are more scientists in the developing world there than from the developed world. And up until this happened, there was a tremendous skepticism among Chinese and Indians and Indonesians and Brazilians and Mexicans and others that this was the latest trick of the rich countries, global warming, to deprive them of an opportunity to repeat the Victorian Industrial Revolution with sweatshops, with coal burning, with internal combustion engines, even if it's 50 to 100 years later, because now there was an excuse. And by incorporating them into the process, having them as lead authors, as co-chairs, as in this case an Indian as the chair of the entire operation, it is absolutely stunning for me to have watched when in the very first IPCC in these plenaries, they were mostly filled up with Western scientists who wrote the literature. And they were not widely accepted by the developing world. By the second and way into the third, when there was a mix of people from different countries, you found countries like India, which you would think would be very skeptical because they want to have development pathways using coal. They want cars. All of a sudden, they were strongly supportive of a strong report because they had such pride that their people were fundamental to the production of the report. So that's the culture of community. It is absolutely critical if we're going to, A, understand the science, that we do it by community, and B, if we're going to ever get any policy, that we have to have coalitions of people with very, very different worldviews who agree that stewardship has to be a primary value. So in that sense, IPCC's prize was really, in my opinion, very important. That having been said, there were some other war stories I will not tell you. Let me ask one other thing. How many people have heard a scientist being asked the expression, or in a debate saying, oh, what do you mean? There's uncertainty, there's speculation, the jury's still out on climate change. That's, yeah, of course. I hear it, I get asked it all the time. So in fact, I have, this is a hard talk for me because my crutch is missing, you know, the PowerPoint. I have some really good cartoons on that. Sorry you miss it. You know, to settle for the fireworks. But so the jury's out. Now, I like to show the cartoon. What it really shows is a little blob of sea ice, and there's Santa Claus and an elf, and everything is melted but the one blob. And then the elf says that the jury's still out on climate change. You know, it's cute. But that's not why I show it. Because what it really is a metaphor. And anything complex that has to be communicated requires metaphors that people can understand. So the metaphor is a jury. So let's unpack that for a minute, and then we'll apply it to complex system science like climate change. If there's a jury trial, and it's a criminal trial, and you're in the jury, the judge, and many of you have undoubtedly been on such trials, the judge tells you what the standards of evidence are. Anybody remember the standard of evidence for a criminal trial? Right, beyond a reasonable doubt. Now, I'm a scientist who deals with uncertain science all the time. And the way my brain works is in bell curves. And they're not just normal distributions of those you know about, that they tend to be right-tailed and Weibold or something else. So we're always thinking bell curves of various sorts and getting as much evidence as we can to do that. So that's very difficult with the jury being out. So of course, the first question that comes to mind is, well, what's the probability of a reasonable doubt? So I asked my lawyer friends, how many people here are lawyers? Only one? Oh, I can really go after them now. Okay, I know some good jokes. No, we won't do that. Some of my best friends are lawyers. One of them even runs my institute. I have to be nice. Now, but the co-runs it. The key is, so I asked my lawyer friends, so what's the probability of reasonable doubt? And they said, that's not our job, that's the jury's job. I said, but what's the guidance? Says, we scientists are very uncomfortable. If somebody asks me, is the science well established? I'm thinking subjective probability greater than 9 out of 10. And they said, no, it's how it goes. I said, let me re-ask the question. What's the likelihood the jury made an error? Same question, actually, just asked in reverse. And the answer I got, oh, well, we don't like to think about that, but we'd probably say in really bad judges and juries and poor lawyers, maybe 1 out of 10, and in really good ones, 1 out of 1,000. I said, boy, it better not be a capital case at 1 out of 10. But in any case, at least there's some implicit knowledge of what that means. Now, what's the other kind of trial? Civil, standard of evidence. Preponderance of evidence, right. What's the probability of a preponderance? Right, more than half. On that standard, global warming has been real and humans have had something to do with it for the last 25 years. Now we're talking about 9 out of 10 and 95 out of 100. So what happens is, as more evidence accumulates from IPCC report to IPCC report, the confidence goes from medium to high to very high. And that's how we tend to view it. And so if you view this as a civil trial, then we have very high standards of evidence where the policy is 25 years late. If you view it as a criminal trial, everything must be established beyond a reasonable doubt. There's still a large amount that are in the competing explanations in the speculative category, and you say, we got to wait. That is not science. That's value judgments about your degree of risk aversion. And very often it gets conflated with science when it isn't science. It's value judgments. It's a worldview about taking risk. And what I want us to do is distinguish between risk, right, what can happen multiplied times the probability, which is a scientific assessment, times risk management, which is, well, what kind of risks do we take? And that's a completely different problem. And I often get asked, well, what do you think the probability is of really catastrophic outcome, like melting of Greenland and 10 to 15 feet of sea level rise occurring in 2 centuries? Well, most everybody in the climate science business thinks if we warm up more than a few degrees C, we're going to melt a lot of Greenland. We're going to get, many meters of sea level rises. Probably might take 1,000 years. It's harder to say how much is going to happen in centuries, which is the lifetime of cities, and that matters to human civilization. So we talk in these subjective terms. But whether that's going to happen, we don't know for sure. What have we got? We've got a 25-year record of ice melting along the margins of Greenland way faster than any of our computer models or our theories predict it should happen. So what does that do? That led Working Group 1, which was the group that looks at the science of climate change, to say, when we make sea level projections, we're only going to use the thermal expansion of the oceans, right? If you heat the oceans, the water expands, and therefore, like the mercury, heat the mercury, it expands, it goes up the walls of the thermometer. Well, if you heat the oceans, they expand, and it goes up the walls, which are called the continental shelves. And that's something on the order of 6 to 10 inches so far, and a couple of feet maybe in this century that you're going to get out of that. Now, that's not great, but that's not meters. And they didn't put in Greenland ice melt. And the reason was, it's obvious that our scientific theory is no good, so we have no basis to make a quantitative forecast. And if you look at it from the perspective of not having that information, you could understand that. I'm in Working Group 2, which is vulnerabilities, adaptation, and impacts. And the 120 governments gave an outline to my chapter that I was responsible for, called Key Vulnerabilities and the Risks of Climate Change. And the word risk management was in our outline given to us by governments. We had to address risk management because the prime directive in IPCC is to address every point you get from the governments. Well, the risk management did not appear in Working Group 1. So they didn't address it. So we did, and we looked at the time when it was 125,000 years ago and it was only 1 or 2 degrees warmer and the sea levels were 5 meters higher, and we looked at the fact that things are melting way faster than now, and we said we assigned a medium confidence, which in the IPCC lingo means 1/3 to 2/3 chance, that there could be 4 to 6 meters of sea level rise in centuries to millennia. Well, that sent my friends in Working Group 1 into a rage. You have no basis for doing that. And we said, you have no basis to ignore risk management. You want us, because you don't know how to do it, to not warn governments that there's this potential risk and so I said, there are 100 planets just like this one. How many do you think, I asked my friends there, how many do you think might have meters of sea level rise from a melted Greenland in 200 years from now? And they said, I don't know, half. I said, well, then you have to go along with it. But that's not how science is done. We don't just guess. I said, wait a minute, you want the politicians to guess for us? That's why we have confidence statements. Why probability matters, but these confidence statements are subjective, because the only way to know for sure is to wait around for it to happen, and that's not risk-free. So the way we reconciled it in our synthesis report, we had to now reconcile this. And I promise you, there were governments. Oh, wait a second. I could shout it down, but I think we won't. There were governments from the small island states and the coastal countries that were cheering us on and thought that we were too conservative because they're threatened. There are countries, particularly the big coal users, that thought it was wildly irresponsible to discuss something that was that speculative. And how did we reach a conclusion? Because Working Group 1 and Working Group 2, in particular, a very smart and honest person named Susan Solomon, who's the head of Working Group 1, and I, in particular, spent a year working out a deal. And the deal that we worked out was something we could both live with. We agreed to drop the numbers, the percentages and so forth. And she agreed to say that there was a risk of meters of sea level rise in centuries. Because she said, I agree that society should know that. And I agreed that although I thought we could make some quantitative statements based on the literature, we'd go along with their reticence. But what were we really talking about? It wasn't science. It was whether you are type 1 or type 2 error averse. Any economists here? Okay, so you know what that means, right? A type 1 error averse person is somebody who's worried about a false positive. And scientists are really type 1 error averse. There was an earthquake talk, wasn't there, recently? And imagine you're an earthquake forecaster in LA and you read your seismic tea leaves and you conclude that there's a 25% chance of a major earthquake in the LA basin this weekend. Now, what happens if you announce that? There'll be a mass evacuation, hundreds of people will die in collisions, thousands will stay behind and be shot for looting. There will be an absolutely major and predictable cataclysm associated with the announcement. So you'll say, well, I'm not going to say that. Can you imagine if it doesn't happen, they'll crucify me. Don't say anything. Maybe tell the mayor. That way they're responsible. Then there's the type 2 error risk-averse person who says, well, wait a minute. Even if it's a 25% chance, supposing it happens, we don't warn them and 10,000 people die. Then we're responsible for that. There's no science. The science is what are the probabilities, what are the consequences. Whether you're type 1 or type 2 error averse, you worry more about the false negative or the false positive, is a value judgment. It's exactly the same thing. How many medical people do we have here? We have several. I know that. I saw Ron Levy out there, and thanks to him, I'm still alive because I had, no, that's not laughing. I have mantle cell lymphoma, and the drug he co-invented is why I'm here. And, but in medical situations, you often have to make these kinds of choices. Supposing you get a diagnosis, a diagnosis shows a lump, and you don't know yet whether it's malignant. Well, you sure are not a happy camper when you get that diagnosis. The question is, if you're type 1 error averse, you'd say, well, let's wait and see if it grows. Let's not scare the patient. Let's not do that. If you're type 2 error averse, you'll say, never mind if the patient is going to have trouble for 2 or 3 weeks. Let's do the biopsy and find out. Because if you wait and then all of a sudden it grows, by that time maybe it'll metastasize. So again, it comes back to making a value judgment. It isn't science. The science is the likelihood it metastasizes, what the consequences are, what treatments you can do, how serious the intervention is to test it. And all of that is why we need good scientists and good doctors and so forth, because the more information we have, the more competent our decisions will be in the risk management realm, where we're really applying our personal values about whether we fear more false positives and false negatives. Now, you can imagine how easy it is for me to discuss this in a 5-second soundbite on the evening news, or the 5 minutes you get in front of Congress. And, you know, in a way, in my darkest moments, what I despair about is whether democracy can survive complexity. I teach a freshman seminar in environmental literacy, and everything we're talking about, we unpack. I have them role play this stuff, because I want them to be literate in understanding how to separate out the components of an argument that are positive, the science part, the risk part, from the components that are normative, the risk management part, so they can separate those judgments out. And then they can have an argument at least where they're arguing the fact part, they're arguing about facts, or they're arguing the value part, they're arguing about values, and not getting them all conflated, thereby leading to utter confusion and this sort of dumbing down that I referred to earlier in the media. So that's part of what we need to try to do, and where climate change is not alone in this. I think it's also true in health, it's true in strategic defense, it's true in dealing with terrorism, it's true in how you approach education. Anytime you have a complex system, there's going to be this well-established competing explanations and speculative. So let me talk about climate for a few minutes, not just the process, and tell you some of the examples that are well-established, some of the competing explanations, and some of the speculative, so you can recognize what you've probably heard in the media. So what's well established? Well, IPCC said that warming in the last 150 years, and they used a language that was not in our guidance, is unequivocal. And that's from looking at the thermometers, the rising sea levels, the melting glaciers, 95% of them are melting, and plants and animals, the work of my wife, of Terry Root, which has shown that plants bloom earlier in the spring and animals come back earlier on migration. That is not only a small fraction of animals and plants have been measured, but of those that have been measured and show change, about 80% of them are changing in the direction expected. And that's such a loaded coin out of 1,000 species that have been followed that we know it's all consistent. So it's warming is well established, but that's not actually a very sophisticated question, because Ma Earth is a very perverse lady. She gives us warming and doesn't say how much is due to her and how much is due to us. That's a much more sophisticated question. Unfortunately, there's no direct empirical test of that, because in order to separate out, you have to have knowledge of process. And to have knowledge of process, you need to have some tool which can differentiate process, and then you can run the tool and ask it by comparing it against actual data, which is more likely. So the way we work it is we take our cloudy crystal balls, which are climate models. They're mathematical statements of the behavior of the atmosphere, the oceans, glaciers, chemistry. They are empirically grounded. They're built on hundreds of years of observations, on theory, on laboratory experiments. But we're running them forward into the future, into a realm of disturbance that's beyond that from which they were derived. So there will always be an element of subjectivity in guessing whether or not the construction that you had, no matter how physically based it is or chemically based it is, you're always nervous. Because even in a model that obeys well-known and believed laws of physics, you can't solve the equations explicitly and exactly, and you have to discretize them into chunks, what we call grid boxes, the size of Connecticut. And single most important element that determines the sensitivity of our climate to how much heating we bring on through greenhouse gases are clouds, and there's no cloud that's the size of Connecticut. They're a lot smaller. There may be a system that's that big, but no individual cloud. So therefore, all the important elements which control the amount of radiation coming in and coming out are smaller than the grain size of our mathematical models. That doesn't mean we ignore clouds. We treat them implicitly by what we call a parameterization, which means a parametric representation. I'll tell you how it works. Clouds really matter. Is it more likely to be cloudy on a dry day or a humid day? Humid, right. So average cloudiness equals parameter, a number, times relative humidity. Is it more likely to be cloudy when the large-scale air is rising or sinking? Rising, because A, it's bringing moisture up with it, and B, it's expanding and therefore will condense. When it's sinking, it's hot and it compresses. That's why deserts don't have a lot of clouds, because the air sinks over them. So therefore, we'll say that there's this term, the parameter times the relative humidity, plus some on-off switch having to do with the air is rising or not. And that is not an explicit, exact physical treatment. But you then do a statistical analysis of how well the model predicts grid scale clouds in wet places and dry places. And the answer is not perfectly, but not terribly either. So then you get into making judgments about, under a very disturbed regime in the future, whether or not that kind of implicit prediction is going to be effective or not. And there are different theories of what kind of ways we should have this parametric representation. And the bulk of the time that climate modelers spend is trying to validate their parameterizations. They're not just out there jumping in front of Congress making scary predictions. Most of the time, they're fighting with each other. And when I said about why the culture of community is so important, very few of us make discoveries that by themselves trump the field. Most of our discoveries are a piece, and we figure out what goes on in those second-rate hotels where we have our meetings drinking third-rate wine unless I'm buying it. And when we go there and people don't know, and we thrash it out. And that's in fact how the community works. And then that's what IPCC does. They thrash it out. These are pretty pitched battles that go on, and people try to come around to what's the better well-established. So it isn't well-established what so-called cloud feedback is. That is, by how much, if you warm the atmosphere, the clouds are going to expand. Because if they expand, they're bright and white, they reflect away sunlight, and they cool back the earth, and they moderate the warming. And the first paper I ever published in the Atmospheric Sciences in 1972 showed that that was wrong. Not that it's wrong that when they get wider they moderate the warming, but if you increase heating and you increase evaporation, you could make the cloud taller as well as wider. If it's taller, the top is higher, the top is colder, it emits less infrared radiation. You physicists know that. As a result of that, you have to warm the whole system up more. It's a positive or amplifying feedback. Or there could be a curve of wider and taller over which there's no feedback at all. In order to answer the question, you'd have to be able to measure the average amount of cloudiness under a changing climate condition to 2%, or the average cloud top height to 0.2 of a kilometer. One of my satellite meteorologist colleagues once quipped, in order to measure it to that degree of accuracy, we'd have to put up so many satellites we'd change the Earth's reflectivity. I mean, it's very difficult, so we don't have the answer. So whether we're going to warm up 1 or 2 degrees more, which is the bottom end with cloud feedback being negative and things copacetic, solar machines having a breakthrough, or whether we're going to warm up 6 degrees Celsius, I'm talking about the temperature difference in an ice age and an interglacial cycle in 100 years, not in 5,000, a catastrophic outcome, is really going to depend upon the outcome of a debate that's not going to get resolved in the next 30 years. Because we can't measure those clouds. There are going to be competing explanations about positive and negative feedbacks. So what's established? It's warming. How about humans? Let's come back to that. How much did humans do? How much did nature do? Well, how can we evaluate it? Well, we take these models with their flaws. We have 6 different species of them that have grown up around the world. They're not all independent, but they all have different codes and different internal dynamics. And each group then takes what happened in the last 50 years. How did the energy output of the sun vary with sunspots? How did volcanoes that throw dust in the stratosphere and block sunlight out? What did that do? We call those natural forcings. You put them in the model. The model now predicts the behavior all over the world at every season. In fact, it does it every 20 minutes, but you average it into seasons. And then you can compare that to what actually happened from 1950 till now, and you get a weak correlation. Very small fraction of the variance, 10% correlation coefficient. Now you force the model with human-induced change. The increase in CO2 and methane and nitrous oxide and chlorofluorocarbons, which we know pretty well. Then you have a slightly more speculative increase in dust, which cools the Earth. Not all, some soot warms it. It's very complex. You put them in as best you understand it. And now you ask the model, by comparing it against the actual observations, what's your correlation? And the answer is you get a correlation coefficient more like 40%. Still, you've got the bulk of the variance not explained, but that's pretty strong. Now you put in a model that's forced by the sum of natural and anthropogenic human forces, and now you start getting correlation coefficients over half. You start explaining up to 50%. There's plenty left for skeptics who want to say we don't have it knocked. On the other hand, you can't go up there with a straight face and say those different results tell you that humans are not already present in the system. So IPCC concluded it's well established. They called it very high confidence, greater than 95%. That I think they said very high. I could have forgotten. It could have been high. Whatever it is, much greater than 9 out of 10. That humans are responsible for most of the warming of the past 40 years. Not the 150 years, because you can't really tell the natural from the anthropogenic until you start getting past 1960, 1970. That's how it works. What about the Greenland ice sheet? Well, it's melting faster than we know. Could that just be internal dynamics of the North Atlantic system, where there are well-known internal modes of oscillation in there? Yes, it could be. In fact, there's some data to suggest it. Or could it be due to global warming, some of which at least is driven by human emissions? And there are schools from both sides. My own personal view is it's both. And in fact, I think the recent stuff, you can make a stronger case for global warming. And the reason for that is glaciologists have gone up on Greenland and they've sunk cores. And they've looked at the last 1,000 or 2,000 years where there are annual layers you can count and found no melting until very recently, the last few years. Now, the likelihood that that's an accident is pretty low, but it's still possible. So I'd call that one in the competing explanation starting to tip toward established, but we're not there yet. But its consequences are major. Meters of sea level rise in a century or two is not trivial from the risk management point of view. Yet we do not have that one out of into the well-established category. Increased hurricane intensities. Let me get toward winding up now. So increased hurricane intensities, like the tremendous increase, the 15% or so increase in Category 4 and 5 hurricanes that have been observed both in the North Atlantic and in the Pacific. Two schools of thought, especially in the North Atlantic. No, it's just an internal oscillation of a complex system, and that it's not due to global warming. And then the other school, which says, wait a minute, thermodynamically, even though we admit that hurricanes are very complex, they depend not just on the ocean surface temperature, which thermodynamically would make them stronger if all the factors are equal, they matter where the height of the tropopause is at, where the stratosphere occurs, because that tells you how deep the clouds can get, how much energy can get released. The depth of the mixed layer matters because a very strong storm mixes it up, and if the warming isn't all the way down, the shear of wind up above is very, very important, because if it cuts off the cloud tops, it won't get strong. Nobody knows how those other factors are going to change with global warming. The one thing we do know is that if all the other factors are equal, you're going to make the hurricanes more intense, and they got more intense. So it's competing explanations again. And what IPCC said is it's more likely than not that the observed increase in intensities to date were due at least in part to human activities, and likely, which means 2/3 to 9 out of 10 in our subjective probability scale, that in the future there'll be increase in hurricane intensities, which if you couple with sea level rise is consequential. What about California? Well, it's in the well-established category. Every computer model says it, and it's been observed, that if you have a Mediterranean climate that doesn't rain in the summer and you add heat, you're going to have more fires. Anybody want to doubt that now? That's been in the forecast for 30 years, and it's been ignored for a pretty long time. The other part of the forecast is that the snowpack will melt earlier, and now it's very noisy. In any one decade, you'll never see it. But if you look over the century and you look at multiple rivers coming out of the Sierras, it's about 2 weeks earlier in the spring, just about when plants are blooming earlier too. It's what we call phenology, or time sequence. These are consistencies, and you never ever hang your hat on one result. You've got to have large number of rivers, very long periods. Remember, global warming is not about what happens in your backyard. It's not about one decade. It's about 30-year at least trends. It's about aggregating over large areas. Remember, all politics, right? What's the old saw? Any political scientists here? Right? The first law of politics, all politics is local, and I would add, and short term, and all climate change is global and long term, so we got a mismatch, on policy. So that's not speculative, but what's going to happen to precipitation in Kansas? We don't even know the sign. That's very important. That's where the breadbasket is. So there are plenty of elements that remain speculative. What's the cloud feedback going to be? That's speculative, but that it will get warmer is already well established. That's why this problem is such a challenge to a functioning democracy. Because can you imagine the Congress trying to make decisions with this kind of information? And we are honor-bound to tell the truth. That's to try to lay out there the whole range from the well-established to the speculative. We do that, we only get 5 minutes. It's not easy. So I use metaphors all the time that try to convey urgency and uncertainty, like loaded dice. There's warm and dry and wet, and calling where we're erasing some of the cool and wet and replacing it with warmer and drier. It's not a perfect analogy, and there's no perfect analogy other than waiting to see what happens. So let me end with policy. California said, our governor and our legislature, and in fact they cooperated. That reminds me, I gave a testimony to the House Ways and Means Committee last year, and one of the minorities said, in a perfectly honest question, how come you guys in California can have a Republican governor and a Democratic House and Assembly, and Senate, a legislature, cooperating. And I said, well, that's because there's no such thing as a early spring Republican flood or a Democratic wildfire. You know, you got to get together when there's a mutual threat. Do it here. And Washington is closer to that than I've ever seen right now. We're getting there. It's in 1997, 95 to nothing, the Senate voted it would not support international climate policy without bringing India and China in, while forgetting the fact, saying it wasn't a level playing field, while forgetting the fact the playing field hasn't been level for 100 years, and that we have a factor of 10 more emissions per capita. You got to give them a little chance to develop before you tell them to take targets, and then we have to help them through it. All of that stuff is now getting recognized. So our governor and legislature called for what I call the 2% solution, that we have to have an 80% reduction by 2050. So that's 40 years, 2% per year average over that time frame. Will that happen? Might be a reporter here, I won't tell you. The probability is not very high, given business as usual. But you know what? If we don't get all the way there, but we get part of the way there, it's a lot better than now. California has the best emissions per capita in the United States, the lowest, because it has performance standards, rules, building codes, these kinds of things. Yet we're still going up in emissions because our population's growing up. So we're flat, but we're still going up. So we have to turn the ship around, even here, the lowest emitting state in the country. And then we have to go flat, and then we have to go down. And there are ways to do it. That's where we need a Stanford, and where we need a Berkeley. And we need places to produce the generation of technologists and social scientists and others who will help us invent our way out of this problem. And that's going to take venture capital combined with innovation, combined with government rules that make it friendly to take some speculative investments. So what's the policy front? First thing we need is we have to recognize we have in the pipeline climate change. No matter what we do, we're going to warm up another degree or two. Not going to reverse this ship that quickly. So we have to have adaptation strategy to help the most vulnerable through that. The second thing is we need to follow the lead in California and get it national and international, and have performance standards, building codes, better refrigerators, cars, and that can make an immediate difference, even in the time frame of 15 years. And it also means that when we start incorporating increasingly the renewables and other currently more expensive than coal systems, you'll need less of it. The third thing is a learning by doing feeding frenzy. We need to invent our way out of this problem by public-private partnerships that help provide incentives. And the fourth thing, which we're talking about now in the form of cap and trade, let's just call it a shadow price on carbon. Think of it as polluter pays. But the trouble with polluter pays is, what do you do with poor people who have a very inefficient car and a long way to drive because it's not their fault? They don't want to do it. It's because that's all they can afford, and that's the way the housing is. We have to also set up side payments and other ways to help people who are disadvantaged by climate policy, not just by climate change. And this calls for two acts of good governance: protect the commons and do it fairly. And in the US, we could do that with some difficulty. We have to do that at the planetary scale. It can be done. And what's lacking, as you've heard many, many times, is not our intellectual capacity. It's not that we haven't got enough knowledge to be able to make a big dent. We certainly need breakthroughs. The breakthroughs aren't going to give us an absolute new technology. They're going to lower the cost of the ones that we need. But what we need is the political will to get on with the job. And a turnout like this gives me some optimism that we may get there. Thank you very much.
I'm sure Stephen will be happy to take some of your questions. There's two microphones running around the audience here, so raise your hand and someone will come by with a mic.
Okay, fireworks time. Comments are okay too, just not 5 minutes.
Yes, I was wondering whether airplane vapor trails were part of the models.
There are models of airplane vapor trails, and in fact, after 9/11, when there was a 2 or 3 day moratorium, the weather forecasts were just, I think they were just a little bit too warm. And in fact, that's also happened when there have been massive fires. And the smoke plumes, which were not part of the weather models, were reflecting away sunlight like the vapor trails do, and they were a little bit too warm. But in both cases, you're not talking about the vast bulk of the number of square meters on Earth. It's in a relatively restricted area, so it has significance in some areas, but it won't be a major factor at a planetary scale. I think the main way that airplanes are going to get in the act is through people like me. I mean, I have a mega greenhouse. We have 3-element windows. We doubled our insulation above the building codes. We have a heat recovery ventilator. All our pipes are clad. And I drive a hybrid and bike to work most of the time. Yeah, and I fly 150,000 miles a year. So 97% of my footprint's in those airplanes. So I think the main way that planes that are part of the show is not so much through their contrails, although in some parts of the world, and especially the U.S. Midwest, that does matter, but through the direct emissions. And we're not going to solve that easily till we start getting safe, efficient, and non-interfering with the food system biofuels. And I'm very optimistic that we'll get there. But that is a frontline R&D and venture way out of the problem necessity.
I've not seen any reports. Mine is a fireworks question.
Go for it.
I have not seen any reports anywhere that gives any statistical data of what the military-industrial complex the world over contributes to global warming, namely the ships, the planes, the cars, the aircrafts, the guns, the bombs, that the militaries of the world, not just the United States, but the world uses. And I think if you went back and calculated the global warming contribution that all the wars of the last century did, I'm sure your numbers will be definitely different. So and I'm from India, and I think we shared the Nobel Prize, Pachauri being from India.
Yes, you did.
So you have to add another 1.1 billion to your 200. But really, disarmament is the only solution to having any answer to global warming. And so we have to think seriously about disarmament. And this has not been addressed by the IPCC, nor by any global warming scientist. And I don't see any statistics addressing how war has contributed. And last question here, how much has Iraq and Afghanistan contributed to global warming?
I'm going to.
Thank you.
Yeah, that wasn't too bad for fireworks. Let me answer the question in a way that may surprise you. I don't think that, I haven't myself done it, but I've heard studies, the military all around, really relative to the massive amount of civilian emissions, is not that large a direct emitter. Where the military becomes really serious, and it isn't just the military, it's the wars that you mentioned, and it's the distrust that are created by military confrontation, is the relative fraction of disposable income and available budget in national governments that goes into that use rather than into inventing our way out of the problem, which is where our real security threats lie. That's where I find that the environmental issues are hurt primarily by wars. When somebody tells me, and I've been told this before, how much is it going to cost to invent our way out of this problem? And the answer is probably tens of billions a year invested in the United States and around the world, at least 100 billion. Oh, that's draconian, that's outrageous, that's out, You know what $10 billion a year is? It's something on the order of 20 DIWs, days of the Iraq War. So when one looks at the budget, one has to look at the whole budget. So I take in your question that it's very difficult to solve a problem where everybody's waste dumped in the system contributes, where not everybody is doing it equally, when they don't trust each other because there's so much conflict and such a large fraction of our resources are spent on conflict rather than on the C word we need, cooperation. So I would say that until we start getting cooperation and cooperative strategies to start replacing the competitive and even more than competitive, the overt hostility that can take place, it'll be very difficult to solve this problem without a lot of warming.
On that point, the reason why the military is so well funded is that there is a well-established infrastructure and a unitary hierarchy to organize it, whereas there's no such thing for the cooperation that we would need or to build the political will. And you pointed this out when you asked whether democracy can survive complexity. And when you pointed out the politics are local and short term, and what we need is long term and global. So I'm curious about your counsel for how, say, everyone in this audience can further the development of excellent policy, given the fragmentation, the interest groups, and all the forces that constrain people working together to figure out solutions that are short-term painful but long-term beneficial.
Okay, very good question. Thank you. Let me start by saying the first thing that we have to do is stop blaming somebody else. It's true, there are others who deserve some blame, but it isn't just the fault of the big oil companies and the big car companies, despite their ads for SUVs and Hummers and other things. The fact is that we're buying them. And we have to start adjusting some of our own ways of doing things. How many of us have told our kids to turn the lights off and they walk out of the room and then we leave the computer on all day? I mean, if there's any way you want a kid not to believe you, it's just don't tell them do as I say and not as I do. These seem like they're little things, but they create that mentality. You tell them to recycle and you don't. So little things at home set a tone. Then we need to form coalitions of neighbors, coalitions of our religious groups or of our political affiliations. And then we have to link those coalitions. You start to become a political force. Politicians start to notice when things link. And seeing Carol Harrington here, she knows that you've been able to accomplish in Palo Alto amazing things by linking coalitions of people who normally don't seem to have aligned interests, but the interests get aligned, all of a sudden they start to become a political force. That's still not going to save the world. Even California's 2% solution, if we did it, we're only the 11th largest emitter. We're still only going to be worth a few percent. And you will hear from some recalcitrants, and I just heard it yesterday at a business meeting I was at. This is one of the oil companies, and they really are doing some good stuff they never would have done 10 or 15 years ago, but they always came out and said, oh, but we're going to be swamped, whatever we do, by Chinese emissions in 2 years. Now, how are we going to go to China with a factor of 7, less per capita emissions than us, and tell us it's time for a level playing field until we walk the walk ourselves? So we have to do it at home, we have to do it in our communities, we have to do it at state level and our national level. Then we start to develop some moral authority to go talk to others to get the cooperative solutions. In order to do that, get cooperation, it requires trust. Now, what kind of trust have we established in the United States? Nobody will be surprised by my opinion of the evidence-free zone that I call the West Wing, is when the largest emitter historically of greenhouse gases, who created the process of cap and trade under one administration, walks away from it in the next one, the largest emitter, and substitutes nothing. How do you have leadership under those conditions? You just look greedy. I believe, and I go traveling all the time, people are out there in other countries just crying for American leadership. And they know they can't do it without us, and they actually trust us when we get engaged to be pretty good world citizens. But right now, we don't have high credibility. So starting at home, working up through those scales, and going through the processes toward eventual negotiations is the only way. One more story in that regard. Back in 1974, a good friend of mine then, John Holdren, and I were at a meeting run by the anthropologist Margaret Mead called The Atmosphere, Endangered and Endangering. And I said, Margaret, why are you running a meeting on that? And she said, this is the last ditch symbol of global interdependence. If we can't solve the climate problem, we can't solve anything. Everybody's threatened. And I remember that we had major battles there, and I was recounting to her some of the difficulties I had with colleagues saying, oh, this is uncertain. Good scientists don't go out in public. They never talk about policy because you can't, do full disclosure, and it's a personal value judgment. So I complained. She said, kid, you can't stand the heat. Get out of the kitchen. That's the way it's going to be. You're going to hear all this stuff from your colleagues, and some of them, and you're going to get told how it's not responsible. She said, but remember, new ideas travel at the speed of transportation. They're global almost immediately. But you're talking about cultural change. That moves at the speed of generations. So for 30 years, 35 years, I've been in this problem. And now we are closer than we have ever been toward getting U.S. national policy, giving us credibility to have some capacity to go abroad and make some deals. And it took, just like she said, about a generation and a half. We're probably 10 years away from real action. That's 2 generations. And it takes time. The problem is the fact that we've delayed so long means it's going to be more expensive, that in short-term pain you mentioned, to solve it, and we'll have to do more than we otherwise would have if we had gotten with the program 25 years ago. But I'm not pessimistic that it's hopeless. I can't cry over the dangerous change that we built into the system by neglecting it, but we can prevent very dangerous change, so let's get on with it.
Thank you. The California Air Resources Board just recently released the scoping plan or the
Yes.
blueprint for implementing AB 32. And I'm curious, do you feel what's been laid out is going to get us to where we need to go?
The one thing that I would say characterizes my view of any complex policy thing is I never let the perfect crowd out the good. And the fact that California has proposed what it's proposed is wonderful. It's a world shining beacon of trying to get bipartisan cooperation working across all sectors. Does that mean everything in it is perfect? No. We still haven't worked out how will we deal with offsets, how are we going to deal with trades, how are we going to value carbon, what are we going to do to deal with other political entities. There are things yet to do, and it'll take time to get there. What are the penalties going to be? What happens if there's non-compliance? There's a lot of issues. Supposing we wanted to practice carbon capture and sequestration, we inject underground. Who owns the underground? Is it the homeowner or is it somebody else? We haven't even touched those issues. So there's still plenty more to do. But I can't get deterred by the fact that we haven't got it all done because we've taken an honest effort to move forward. And at the moment, it's the most progressive set of rules in the planet. And so we've got to have a learning by doing experiment. It's a social experiment. And I think California can be very proud of its leadership. And that's one of the reasons why, since California had rules that predated the Clean Air Act, why California can get a waiver, an exemption from the EPA when it has rules that are stronger than national average. And every single waiver it's applied for has been accepted until this year when this administration, the evidence-free zone, denied the Pavley Bill waiver, AB 93, which is California's tailpipe emission standard, which will have about 12 other states lined up. I've forgotten what the current number is, because it wasn't convenient to the campaign contributors to the administration. And that is going to change. Both candidates have said they're going to approve the waiver, and the courts will probably approve it. We move forward haltingly, but we move forward. And I can't get too pessimistic because we haven't moved as fast as we should, or AB 32 isn't perfect.
My wife and I have been working the last couple of years to shrink our carbon footprint. But I'm also thinking about the 54 years that I was alive before I saw An Inconvenient Truth. And it seems to me morally necessary to somehow offset the emissions that I produced up until then and the emissions that I'm still producing. Do you agree that that's a useful step, and how would you suggest one offset a vast amount of carbon emissions?
Yeah, that's a very good question. Also, in fact, in my my graduate seminar, at least 2 student groups always take on the offset question because the question is, are the tons real? And you don't want to buy a pig in a poke. You want to buy real offsets. So let me begin by saying that those people who believe that their carbon footprint is something that they're not proud of, even though they know it's inevitable, and they want to go out and they want to buy activities that somebody else performs that sequesters carbon, I admire them for doing it. But I want to make sure they're buying real tons. So there are some organizations, I've forgotten which, I think TerraPass is the one, that only deals in solar or wind or things where you're replacing and displacing fossil fuel production. Those are virtually certain to be real tons saved. There are others which include forests. Now, a forest is something that does sequester carbon, and it's a good thing. And in fact, protecting primary forests, particularly in the tropics, is a very good thing because not only are you saving the carbon by keeping it in the ground and not sending most of it in the air, but you're also protecting biodiversity, which lives in its largest abundance in tropical forests. So it sounds like a double win. The problem is, if somebody's getting paid a lot of money for protecting 10,000 hectares in Nicaragua, and then 20 kilometers away they're cutting down 20,000 hectares, you haven't done anything. All you've done is made people rich, and you haven't saved any tons. So in order to make forests work, you have to have a baseline. A baseline is a counterfactual. It's by how much would deforestation have taken place in the absence of the climate policy. It's what in the UN language is called additionality. It has to be additional to what otherwise would have happened. Well, how do you know what otherwise would have happened 25 years from now? Unless you have a twin Earth that you've been able to go visit the future, you're not going to have it. So you have to do a trade negotiation. You have to look at the rates of deforestation, the rates of development, what the country would have done. And then if you can assign a baseline, then you can now have a real measure against the national deforestation rate and find out were those tons real. This was absolutely ruled out in most of the meetings of the UN Framework Convention on Climate Change, the COPs. I happen to have supported having primary forest protection with baselines. But now the pendulum has swung. WWF, the World Wildlife Fund, that was against it in the Hague meeting in 2000, is cautiously in favor with monitoring and with baselines. So I think that we can start getting these offsets to be broader and quite real. I would hope that any large construction company or large engineering building design company that builds insulation and windows that are better than the building codes, they should be able to get offset money for that. A farmer that used to plow and disc, that now does stubble agriculture, should be able to get offset money for that. And that way you encourage people to do the right thing. The problem is, if everybody had to have a cut in their emissions or pay for it, there wouldn't be enough offsets left. What there would be is a market. And the market would settle at the lowest price that anybody could get from the cleverest entrepreneurs who are able to cut tons at the cheapest rate. That's exactly what was envisioned in the US cap and trade program that the Kyoto Protocol bought into and eventually was signed onto, is the notion that you could try to do it as cheaply as you can. But if everybody cut, then at the margin there wouldn't be any tons left. So right now, because there's no global climate policy, there's only sporadic state or national policy, there's still tons out there to get, and I don't in the slightest judge anyone negatively for going for it. The way we did it at home is we chose, rather than, and I'm not sure I'm going to continue this, I might start buying offsets, we chose to put the 3-element windows in our house and the double the insulation and so forth, because I knew that those were real tons. But I think now that some of the offset companies look to me like they're also doing real tons. But sooner or later, when there's national policy and there's international policy, we'll just have to have larger scale mechanisms. And there'll be an offset market. And the offset market will be buying carbon at the lowest price that can be available out there, like the Chicago Exchange does. So go ahead now, but just be careful. Check it out. Make sure what you're buying is real.
That's actually a good lead-in for my question, which was trying to understand the interaction between climate change, peak oil and gas, and what the economists seem to think. And the question sort of goes like this, is there's been all this work in the last year or two, especially with the Stern report, right? Modeling the future and how much does it cost to actually save the planet, right? And of course the economists have had arguments in all directions, right? The odd thing to me was that peak oil, all my geology friends say it's real and it's here, or coming soon, feeds into the economy, and yet that doesn't seem to fit any of the 6 or 8 different models I've looked at. Because if you believe, I think you know Bob Ayers?
Yes, of course.
Okay, all right. You look at his
From
models.
Carnegie Mellon.
Yeah, and you look at his models, and if we don't save, they're getting much more efficient. The economy goes down, not up, because all the economists seem to think we're going to be 7 to 10 times richer in the 2100. So how, the real question is, how are you interacting with the economists? Because the political will to do something depends on them some.
Some of my best friends are economists. How many economists here? I asked the lawyer's question. Only a few of you. Oh, good, you're in trouble. No, no, no. We can't live without them, and sometimes it's hard to live with them. And first of all, we don't have infinite resources. Costs matter. If you spend money on one thing, you have less of it to spend on something else. Opportunity cost, which is a principle of economics, is absolutely real, and we have to deal with it. Where I start having a problem with some of my economist friends is to think that the rational principle is to monetize everything and then discount it at the cost of money, which would be equivalent of saying you love your child more than your grandchild. Because if you're discounting the future when you're talking about life and death, it's not the same thing as when you're talking about equivalent cash flow transactions where discounting matters, because then it makes sense when you're competing them against just returns. When you mentioned the Stern report, Stern said that it was economically rational to have a very large investment in hundreds of dollars a ton carbon tax equivalent, which would radically alter the economics and replace conventional energy with alternatives because of the damages. But what he did was he looked at this bell curve of damages, and the economists who try to look at damages, it's not an economics question, it's an ecology question, an agriculture question, a forestry question, a hydrology question. They sort of look at that and then they try to squeeze numbers out of them in dollars for a whole range of services. He did go over in the right-hand tail of the damage function. In other words, he was practicing risk management by risk aversion. I'm for that. However, he didn't quite tell everybody out there as well as maybe he could have that he was selecting from the right-hand tail of the distribution. So economists went nonlinear, that he was distorting what they had published because he was ignoring the median case and then going out to the risk management case. So when I get asked about, well, how can you justify that? Shouldn't you look at the median? I generally like to say, well, okay, how many people here have had a serious house fire? A couple of percent maybe. How many of you have fire insurance? Fools. I mean, my God. I mean, the expectation is very low that there'll be a fire. Yet we're risk averse because we have that value of not wanting to make the type 2 error. So I don't think Stern was wrong to focus on very large damage outcomes as a precautionary measure, but you also have to talk about what the costs are and the opportunity costs. And so I think we can't, as I said, we can't live without them, and sometimes it's hard to live with them, particularly when they're over monetizing and over discounting. But they got to be there. Let me differentiate where I have my standard argument with my economist friends. I don't think that you can do global warming as a cost-benefit analysis, because I don't know how to monetize the benefits to the shipping industry of a shorter route across the Arctic as the sea ice melts versus the destruction of the Inuit culture in the polar bear ecosystem. How do you monetize that and run them with a single number in a model? I don't think it's possible. I think that's a political decision about gut check values, not an economics decision. However, once you make a political decision about how much carbon you want to cut, out of your emissions, we darn well need the economists so we get there as cost effectively as possible, because it's absolutely stupid in a constrained, resource-constrained world to throw away money. So we need to do cost effectiveness. It's arguable about whether we should be doing cost benefit, because I don't think I know how to define it. And it's a standard argument with many of my friends in that profession about how do you apply it. I said, just tell me, how do you want to use the value of a statistical life? The IPCC in its second assessment report in Working Group 3 did that. They assigned $10,000 of statistical life to the average Bangladeshi who would die by the thousands in intensified hurricanes and rising sea level, and then the beneficiaries of high northern latitudes that have less respiratory flu and it's warmer, and they went to Belgium and they used $2 million for a statistical life. You can guess what happened. It got thrown out by the UN countries as absolutely immoral and absurd calculus, because how do you do $1 one vote when people don't have an equal stake in who created the problem or in the economy to fix it? So those are part of the political calculus that we have to deal with. And to me, this problem is primarily political, but it has an important economic component that can't be thrown out, but has to be in the right perspective, which for me is cost effectiveness. Somebody had a question in the front, but no mic. Oh, there we go.
You mentioned cap and trade a lot. It seemed to me that carbon tax is just really simple, straightforward, not a lot of complexity to it. But you seem to be favoring cap and trade. Can you comment on that? The second thing is, I went to a seminar a while back and talked about methanol as a fuel. I haven't heard anything at all about that. Flex fuel cars. Can you also comment on that?
Okay, yeah. Let me do the methanol first, because I just was at an oil company yesterday and sat next to the guy who deals with their biofuels, and I asked exactly that question. Why don't you do methanol? It's got a lower boiling point. You know, you don't have as much energy to distill it. And of course, I got the standard answer, which is, well, you have to put it in containers that are better, and it's very hydrophilic, and it soaks up water, and it's hard to do that. And I said, yeah, but ethanol is not a very high energy carrier. And they said, well, these new, what are they, iso alcohols? I don't know even what they are. They're new chemicals that apparently have very high energy content. And then there are some really brilliant ideas I've heard. This is the learning by doing feeding frenzy, with people wanting to take CO2 out of stack gas and then put it right into algae factories internally, and then producing from that very high energy density fuels like biodiesel, except not doing it by mucking up our land, you know, and taking away food crops. So I think there are some really brilliant ideas for creative entrepreneurs out there. I personally like methanol, but we have to deal with this storage problem and with the other problem. Ethanol. Everybody who's environmental loves to hate ethanol because it's not the long-term solution. On the other hand, it's sort of been the way that we started to move into it. So I don't want to criticize people who used ethanol to start moving us into biofuels. It clearly can't be the long-term winner if we produce it the way we're currently doing it with corn. But biofuels they have to play a major role, particularly in transportation fuels. As regard to the other question, remind me again, it was about economic, oh yeah, cap and trade versus carbon tax. I didn't favor it because that's my favorite. I happen to be a guy who actually prefers a carbon tax. But let me give you the pros and cons. The industry prefers a carbon tax because it controls costs. They know what they emit, they know what it's going to cost them. So they can do a business plan that works within it. The environmentalists don't like carbon taxes, and that's because they don't really know how many tons are going to get saved at any given price. So by specifying a cap, you know you're going to stay under a certain amount of emissions. The industry worries that if the cap is too high, the price gets so large that it's uncontrolled costs. So some very clever economists, like some things the economists do, at Resources for the Future came up with a hybrid scheme where they said, okay, let's put their money where their mouth is. If they're really afraid that a carbon tax, that a cap is going to get so high, then what we'll do is we'll cap the cap and have the government sell at effectively a tax, a permit price, and that way the hybrid scheme will ensure you won't have that economic uncertainty beyond a certain amount. So there are some clever ideas out there. I went to Kyoto in '97 and made a complete pariah of myself because I argued that we should have a globally collected, not national states, because then they use it to substitute for taxes. And we should have a globally collected international carbon tax. Everybody, including China and India, should be in it. But that we should recycle revenues for at least 25 to 40 years in decreasing proportions to countries that hadn't yet had their share of atmospheric emissions. This was my wild plan. And of course it went nowhere, and still is nowhere. And I can give you the reference for it if you care about it. I wrote about it. And the other thing that we need to do is we need to be careful about just declaring targets and timetables, because the whole Kyoto model was on, we're going to cut by X percentage and Y time frame. So I went up there in a press conference and at a session, in fact, with Pachauri before he was running IPCC, and I gave a metaphor. I said, well, I'm getting a little too heavy, and boy, it's worse now than it was then. And I said, so I'm going to announce a target. I'm going to lose 10 pounds. I'm going to give you a timetable next year, but I'm not going to tell you how I'm going to do it. That was what was wrong with the targets and timetables. They weren't policies and measures. They were aspirational. So I said, what's going to happen is I'm going to get on the scale in November. Remember, these meetings are in December. And I'm going to say, oops, new target, 12 pounds. New timetable the following year. Or the other thing I could do is I can announce a policy and measure, not pretend that I'm just going to get there. I'm going to eat 2 desserts less a week. Then every month I'm going to get on the scale and I'm going to figure out whether or not I'm going faster or slower than my aspirational time scale, my target. So I still have a target, but I'm going to have a policy and measure as the primary announcement, not the target. And if things are going great, I can go back to 1 dessert. If they're not going so well, maybe I have to get rid of all my desserts. Maybe I have to start doing some exercise. Whatever it is, you've got to be able to have an ordered set of policies. You can't just have aspirational goals. So in the AB 32 answer, there was aspirational goals. Now they're trying to work out the ordered set of policies so that we can try to get there. The same thing has to happen internationally. Just so cap and trade is equivalent to a carbon tax if it's enforced, right? If there's a cap and it's going to cost something, there's going to be a shadow price on carbon, you can trade to get the lowest price. You could announce a price on carbon, and then you could still allow trades. People could, if they could get it cheaper by buying it instead of by cutting it home, why not? I mean, you could have tax and trade too. So they can be equivalent, but somehow the T word is just politically impossible in the United States. So you were right, I was talking cap and trade because that's the current political reality. Will that political reality also be there after the next president takes place? Probably, but maybe not. So we'll stay open. The main thing is we have to have policies and measures one way or the other, because just having aspirational goals will not cut tons.
Last question. Professor, I have a odd question for the evening. Oh, am I in the light feed?
Oh, I gotcha. Okay. Thank you.
This whole evening, hearing about climate change, you're right, this is a major issue. We're all really worried about it. But what gets me is, is it worse for me to fly back to the East Coast or to eat Chilean sea bass when I get there? And what I mean by that is, should I be worrying about the immediate... What should I worry about? But I have no idea how to compare it to all the other ways we're destroying the world.
Okay, let me answer it without even talking about other environmental challenges. I got asked the other day, you must think climate change is the most serious problem in the world. And I said, no, you'd be surprised, but I don't. I think avoiding massive use of weapons of mass destruction has got to be our priority 1. Although I don't agree with the way some of us are approaching that, but never mind, that's not what we're here for tonight. And number 2, the fact that this planet has been, in my opinion, morally bankrupt in neglecting the sustainable development debate, where there are billions of people without clean water, improperly fed, without health care. Now, what does climate do? Climate comes along and makes those problems worse. And at the moment, we have been so derelict in not putting in the $100 billion a year that it probably would cost, which is not, by the way, a very large fraction of the growth rate of our economy. Our current economy, let me divert for a second, our current economy is about 50 trillion. It's growing about 4% per year, maybe 2 in the US. So at 4% per year, that's $2 trillion added on a year. If we want to fix this problem at a few $100 billion a year, we are not talking about bankrupting the economy, which is what you hear from the evidence-free zone. What we're talking about is a small fraction of the growth rate of the GDP. We're 500% richer in 2103 with very low climate change, or we're 500% richer in 2100 with a massive amount. It is not a macroeconomics catastrophe. And anybody who doesn't believe that had better look at the fact that we've had $80 a barrel oil increase in the last year, which is a $200 a ton carbon tax, which is as higher than anybody's proposed element, and the economy is still here, thank you. And if we were going to do climate policy, we would have done that in 10 years, not in 1. So I think we could clearly say that there's a lot that we could do. However, at the moment, climate change seems to be a threat that everybody holds in common to differing degrees. As a result of that, it may be, and I'm being very cynical, the only horse we have to ride right now on sustainable development. So if we can find ways to link policies which reduce climate change as well as reduce our vulnerability to climate change, help with adaptation, and that they're part of the sustainable development agenda, I think then we can start working on some of the great problems in the world. And the other environmental problems you mentioned are also important. Species extinction, which I just barely mentioned with regard to polar bears, IPCC predicts somewhere between 10 and 40% extinction, depending upon whether we warm up at 1C or 4C. And the reason that the extinction numbers are so high is not due to climate change per se, but due to the fragmentation of habitat, the classical reason environmental groups collect funds to try to protect habitats. Now you change the climate out from under them, make them cross factories, farms, freeways, and urban settlements. That's what leads to a threat. So I don't want to start ranking these and then say we only do the first one and then we do the second one. I think we should look to the synergisms, the interactions, try to solve more than one problem at once, which is the high leverage strategy of good businesses, and that way you get more bang for your buck. And that requires, again, cooperative solutions and an engaged public. So thank you very much for being engaged.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.